So since the problem arises with Newtonian mechanics when it comes to motions which are constraints, let us briefly discuss about constraint motions. What do we mean by constraint motion? For example, when an ant, so let us discuss about constraint motion. Constraint motion. Okay, now for example, if we take an ant which is moving, which is just allowed to move in xy plane. So what is the constraint that we are applying on the ant? The constraint that we are applying on the ant is the following, that it cannot move along the z axis or in the yz plane or xz plane. It can just move in one plane. So here the constraint that you are applying is z equal to 0 for an ant moving in xy plane, isn't it? Suppose while watching a circus, a performer is moving on a rope tied in the x direction. So what is the constraint for that performer who is moving in one direction? It is restricted, the performer is restricted to move only in one path, in one direction. Okay, the others are 0. So y equal to 0, z equal to 0 for a performer moving on a string in x direction, isn't it? In x direction. All right. So you see, therefore this is how these are the meanings of constraints, as you can understand. What is the constraint regarding a rigid body? When we take a rigid body, suppose say, for a rigid body, what constraint do you apply? Well, for rigid body, distance between any 2 points within the body should always remain constant, isn't it? That is the constraint for a rigid body. Distance between any 2 points in a rigid body is constant. So this is the constraint for a rigid body. So these are the various constraints that we talk about. All right. Now, well, therefore, how also, suppose say if you take the motion of a pendulum, well, mathematically, considering the motion of a pendulum, if you take it as an example, the motion of a pendulum, okay, for a pendulum of length L, okay, what happens? What is the equation of motion that describes the pendulum's motion in Cartesian coordinate? It is x square plus y square is equal to L square. The equation describing the motion, the constraint equation. Okay, it's the constraint equation describing the motion. Okay, constraint equation while the pendulum is in motion, while in the motion. Okay, so this is in Cartesian coordinate system. Now suppose you express it in polar coordinates. Well, in polar coordinates, you can say the same equation you can write as R equal to L. This is the equation, the constraint equation mm, in Cartesian coordinate. This is in Cartesian coordinate. Okay, in Cartesian coordinate. This is the same in polar coordinate. R will be equal to L. Alright, so what do we observe? From these two equations that we see, we observe that the constrained equation for the polar using polar coordinate is much simpler compared to Cartesian coordinates where more variables are involved. Okay, same thing when you take for so for motion of a pendulum, if you take the motion for a particle restricted to move on a sphere. When a particle is restricted to move on a sphere, then its equation of motion is in Cartesian coordinate x square plus y square. In Cartesian coordinate, its equation is x square plus y square plus z square equal to a square, isn't it? This is in Cartesian coordinate. Cartesian coordinate. Alright, when we try the same in polar coordinate, what do we write? R is equal to A in polar coordinates, where A is the radius, polar coordinate system. So this is much simpler. So one has to look for simpler options while describing equations of motions which are supported by which have constraints. Okay. So based on, first and foremost, before writing the equations of motion, one needs to consider the different types of constraints that one can come across. And well, once we have an idea about the different types, when we classify the constraints under various categories, then it becomes easier for us to describe the various types of motions and write down the equations for different types of motion. So what are the classification of constraints? When we classify constraints, when we do the classification of constraints, when we do that, well, we find that we can classify constraints as scleronomous, rheonomous, holonomous and non-holonomous. Basically, we make 4 broad classifications. What is it? That the constraints are scleronomous, I think let us start off with holonomous, non-holonomous, holonomous. So they sound big, but they are actually, they mean meaning is quite simple. The description is quite simple, but you need to know it. Holonomous, non-holonomous, scleronomous, and rheonomous. Or holonomic, non-holonomic, scleronomic, and rheonomic constraints. So these are the different types of constraints. So let us discuss the constraints one by one. Okay, so let's stop over here.